So as we start the second half of Unit 8, we're going to begin looking at logarithms. To start this activity, we kind of worked together and took a look at some collections of numbers, kind of almost like puzzles, and try and figured out a pattern and wrote in some values that made these patterns true. So what I'd like for you to do now, somewhere at the top of your note page, thinking about what we did together in that activity, is to write down in your own words what this equation says. Log base b of a equals x. Take just a few minutes to do that. So we begin by thinking about the idea of a logarithmic equation. We spent some time last week and the week before talking about exponential equations. Exponential equations had the variable and the exponent. A logarithmic equation is an equation that contains a logarithm. As an example, log base 5 of x equals 4. Can we solve this for x? So there's a relationship between these exponential equations and the logarithmic equations. B raised to the x equals y, and log base b of y equals x. The log is the exponent. So y equals b to the x power. 3 to the 4 equals 81. Then we say, well, the log base b of y equals x, so the log base 3 of 81 equals 4. The log is the exponent. We could think of this as inverse operations. Logarithms and exponentials undo each other. So what is 2 to the 5th power versus to what power can I raise 2 to equal 32? Go ahead and pause the video and take a couple of minutes to write some of your own puzzles like we did in the activity in class that follow these patterns. All right, so let's take a look at some examples. We're going to take these logs and write them in exponential form. So the log base 2 of 64 is 6. So remembering that b to the x equals y is the exponential form, log base b of y equals x. So the log base b of y equals x. We're going to rewrite this as b to the x equals y. So the b is the base, 2, x, well that's the log. That's going to be our exponent. And then y is the value. So the expression log base 2 of 64 equals 6 is equivalent to the expression 2 to the 6th equals 64. So log base 4 of 1/64 equals -3. So the base is our base. The log is the exponent, and then the value. 4 to the -3 equals 1/64. Log base 3 of 1/3 equals -1. Well, to what power could I raise 3? That gives me 1/3 as an answer. You go, oh, that's 3 to the -1 power. Exactly. Now let's try to go the opposite direction. Let's take an exponential expression and rewrite it in logarithmic form. So remembering again, log base b of y equals x is equivalent to b raised to the x equals y. So b raised to the x equals y. We want to rewrite that in the form log base b of y equals x. So log, the base was 2, the value y, 32, and the log is the exponent. So log base 2 of 32 equals 5. Similarly, 3 squared equals 9. What's my base? It's 3, so that's going to be the base of the log expression. Okay? The value, and then the log is the exponent. Log base 3 of 9 equals 2. Here's a log in base 10. Okay. My log is my exponent, -1, and the value, 1/10. So can we use this to solve some equations? It turns out that sometimes we can solve a logarithmic equation by changing it over into an exponential equation first and then solving for that variable. So as an example, solving this equation, log base 5 of x equals 4. So thinking about what we're saying, 5 is the base, the log is the exponent. So 5 to the 4th power is going to give us the value of x. Ordinarily, if we look at that as an equation, log base 5 of x equals 4, we kind of puzzle at that for a minute until we recognize that logarithms and exponentials are inverse operations. They undo each other. So if I write this as an exponential, the base raised to the power equals the value. So 5 to the 4th equals x. Well, 5 to the 4th, 5 times 5 is 25, times 5 again, 125, times 5 again, 625. So the log base 5 of 625 equals 4. How about this one? We just wrote this example in a previous screen. Log base x of 32 equals 5. Okay, so x is our base. The log is the exponent. So we're asking ourselves, what number raised to the 5th power equals 32? Take the 5th root of each of these. And the 5th root of 32 is 2. So pause the video, take just a moment, and write down something you think that you might type into your calculator if you were trying to find a value for x that makes this statement true. 10 to some power equals 123. 10 to the x equals 123. What's x? So the log is the exponent. Log base 10 of 123 equals x. So let's look at some special cases. When we're given some log expressions and we convert those over into exponentials, we can see that there's some common expressions that can easily be simplified and actually memorized without having to put them into a calculator. So let's look at a couple of those. The log base a of 1 is 0. How could that be? Well, if a is the base and the log is the exponent, that's a to the 0 power, and that's 1. So the log base a of 1 is equal to 0. What that's saying is the log of any base of 1 is going to be equal to 0. The log base a of a equals 1. How can that be true? Well, we look at that, and anything to the first power is itself. So the log of a value in that same base of the value, it makes sense that that's 1. Log base a of a to the x, well, that's going to be equal to x because the log is the exponent. And so log base a of a to a power is equal to the exponent. A to the x equals a to the x. So let's look at a couple of examples and let's see if we can use those special values to try to simplify some expressions. So the log base 2 of 4. Let's write it this way. The log base 2 of 4 equals x. So we're kind of thinking to ourselves, what value could I put on 2 as an exponent, that would give me 4. Using these special values, though, we can kind of rewrite this. Log base 2 of 2 squared equals x. It's pretty easy to see that x equals 2. Similarly, log base 3 of 27. That's like saying the log base 3 of 3 to the third. That's going to be equal to just 3. Log base 4 of 1. So 4 is the base. 4 to some power equals 1. Well, what power can I raise 4 to that gives me 1 as a value? That's equal to 0. Remember, the log, any base equals 1. That simplifies to 0. The log base 8 of 2. So the log is the exponent. So let's see what we have here. Log base 8, 2 is the cube root of 8. That's 8 to the 1/3 power. Is that something that I'd expect you to recognize? Well, maybe it doesn't jump out at you right now, but part of our job when we simplify these is trying to knock these things down to a base that's recognizable. So log base 8 of 8 to the 1/3, that's equal to 1/3. Log base 3 of 3. That's saying to what power can I raise 3 so that it's equal to 3? Clearly x has to be equal to 1. And the log base 2 of 1/2, so that's like saying log base 2 of 2 to the negative 1 power. That's going to be equal to negative 1. Be sure to take some time and write your summary of the notes. 3 things that you learned today, 3 things you want to know more about, and 1 big question you still have. And this is an area that I think we could make a lot better use of as we move on through the course of the year. Any kind of connections you make with things that we learned earlier or things that you found out about in other classes. If sketching things out helps you to understand a little bit better, or things that popped in your head while you were taking these notes, be sure to write those down here as well.